class, and welcome to demonstration video number 1 for chapter 14. And this chapter will be on, once again, like I mentioned in the introduction video, bonds. And this is kind of like a continuation of chapter 14, getting into bonds and using the present value tables for these bonds. So I'll show you brief exercise 14-2 first. We'll get into 14-2, and I haven't created the tabs yet, but we're going to get into 14-3, exercise 14-3, exercise 14-9, and those are the ones I'm going to do in this video. The second video would entail 14-22, a brief exercise 14-11, and 21. So that's going to be in the next video, but for now, these are the ones that I'm going to do. So I'll have the tabs once again down here, and I'll attach this to the video so that you can follow along once you are done watching the videos, or if you needed to help you out with homework. Okay, so let's start with brief exercise 14-2 first. It's on page 837. Or excuse me, on bottom of 836. Okay. A company issued 5% 20-year bonds with a face amount of $80 million. The market yield for bonds of similar risk and maturity is 6%. Interest is paid semi-annually. At what price did the bonds sell? Okay, so for this situation, we're going to need our present value tables at the back of the book. And remember, they're kind of like marked in the green color. And it's in the back of the book. It starts on page P-1. Okay, so for this exercise, this is the way I'm going to lay it out. We have to first calculate interest, and it's going to use a different table because interest is paid with a series of the same amount. So it's more than one payment, so we're going to use table 4 for that. So basically, what we're going to do first is we're going to take $2 million. Okay. We're going to multiply that by the factor. And our factor, let me just write it down here. Our interest is going to be, we're going to use, our number of periods is 40. Okay, N is 40. Our interest is 3%. This is calculated semi-annually, so once again it's 6%, but because it's semi-annually and twice, our interest is 3%. So if we look at that factor, or those terms under table 4, our factor is going to be 23.11477. So you can multiply that 2 million by 23.11477. So that should equal, so I'm going to put in my formula here. Okay. It's going to equal 46,229,540. Okay. Those are all of the interest, or the present value of all the interest that would be paid. And then the principal, we will have to use a different table because the principal is only one payment of 80 million. I'm going to multiply that by, okay, so for the principal, do that down here. Our N is going to be 40 because it's for 40 years. Interest is going to be at 3%. Okay, once again, it's, and let me just do this, table 2, so that you can remember. Once again, it's paid semi-annually, it's 6%, but we're going to use 3% because it's paid semi-annually. Table 4, there. Okay, so if we look at table 2 for number of periods of 40 and then 3%, our payment factor is going to be 0.30656. Okay. Oh, and I forgot this too. This right here, the interest is the, sorry, just threw that out at you. Realize that I didn't. It would be 5% divided by 2. Oops, come on. Times 80 million. And if you do that calculation, it should equal 2 million. Okay. All right, so let's do our calculation. 80 million times 0.30656, and it should equal 24,524,800. And if we add this up, oops, let's insert, okay. If you add this up, our total present value then or the price of the bonds equals 70,754,384. Okay, so that is brief exercise 14-2. That's the way we would lay these out here. Let me just highlight that for you. Okay, and each of these is calculated down here, right there, and that one here. And let's do this here. There. Okay, so that you know where those numbers came from when you come back to these notes. Okay, so moving on 14-2. All right, 14-2, I've already created that table that they submitted in 14-2 on page 838. As you can see, they've got the maturity date, maturity in years, the interest paid, the stated rate, and the effective market rate. There are 5 different scenarios, and they want us to determine the price of a 1 million bond issue under each of the following independent assumptions. Okay, so assumption 1, and this is the way we'd like you to set it up again, like how I just did here. Okay, I'm going to go in and just copy this over so we don't have to. Let's do, yeah, values. That's fine. Okay. Okay. And then principal, let me just copy that over. I could have done it at the same time. Okay, no fill. Okay, so for our first scenario, and for under each one, I'm going to do the same thing. I'm just going to copy this right over. Okay, but I'll change these areas in here. Let me just highlight that so you know where each assumption is once you get into it. Okay, so for assumption 1, let's delete all this here. For assumption 1, it's at 10%. Interest is paid annually. So because it's paid annually, it would just be 10% times the 1 million. Okay. And that should equal 100,000. Okay, so our interest is 100,000. And let me just fix on my cells here. Okay. Let me just do this. And same here. So I don't have to go back and do that. I'm going to do this. This will be percentages. percentage, 2 decimal places. Say okay. All right, there we go. Okay, it should be okay now, hopefully. Okay, so for this first scenario, we've got 10 years, interest paid annually, stated rate is 10%, the effective rate is 12%. Our interest is 100,000, which is 10% times 1 million. And our factor then for the interest is 10 periods at 12%. Okay. Notice that we're not dividing it by 2 anymore because interest is calculated annually, only once a year. So our factor here in table 4, because we're going to be using the same table because there's a series of equal payments, using table 4 for present value, our factor is going to be 5.65022. Okay. And what I'm going to do here, and this shouldn't be, this should just be a number. I'm going to format my cell again. Okay, there you go. Should work now. And I'm going to put formulas in here so that once I type these in, our formulas, our numbers come right up. Okay, that's the magic of Excel. I love Excel for that. It saves a lot of time. Okay, and then for the principal, it's $1 million, okay, which is up here. And our principal number of periods is going to be the same, which is the 10. Then our interest is going to be at 12%. Okay. So that means if you look on table 2, for the factor, our factor should be 0.32197. So let me just enter that in here. And voila. Here's my present value of the principal is $321,970. And once again, I'm going to put another formula in here. So our total, I'm just going to go back here, copy, and paste it here so we don't need to rewrite everything over and over again. So my present value then for assumption 1 is, I'm going to redo. Present value of the bonds then is $886,992. Okay, so that's assumption 1. Bear with me, I'm going to put a page break in here. If I can find it, since they changed everything around. Let me just pause it. Okay, here we are, back again. Okay, so basically that's what we have for assumption 1. I'm going to go ahead and copy this. I'm going to paste it here. Okay, and I will just change this to 2. And our interest will still be, it won't be 100 because in this situation it's 10 years, but it's semi-annually. So basically we're going to take that 10% divided by 2, and then we're going to multiply it by 1 million. That should be half of it, which is 50,000. Interest then is going to be used, well, we're going to arrive at interest by using table 4. Number of payments is going to be 20 instead of 10, because if you take 10 years, and if you calculate interest twice a year, that's 20 periods. Okay, then your interest will be at 6% instead of that 12% here. It's going to be 6% because it's calculated twice a year. Then our factor should be 11.46992. So let me just enter that in here. So interest is 50,000 times our present value of an ordinary annuity. The payment is payment factor is 11.46992 for a total interest of 7,573,496. All right, principal is still at 1 million, and our factor then is going to be at 20 periods for 6%. And if we look at table 2, the factor we use should be 0.31180. Okay, so with that, our present value price of the bonds for assumption 2 here is 885,296. Okay, once again, I'm going to paste and do this. I'm going to scroll up. This is assumption 3 now. Okay, for assumption 3, the stated rate is at 12%, paid semi-annually. So we're going to take that 12% divided by 2 times 1 million. That should get us to 60,000. So 60,000 here. My payment factor for the present value of an ordinary annuity, my number of payments is 20 payments again because it's paid semi-annually, and my percent is 5%. Okay, because my effective rate is at 10%. Well, it's calculated twice a year, so I'm going to take half of that, which is 5%. That will make my factor in table 4 be 12.46221. My interest then is 747,733. My principal is going to be at the 1 million. Okay. Then my number of payments is going to be the same. My interest is going to be 5% instead of 6. And my factor for that is 0.37689. So that gets us to present value of the bonds at 1.1 million, 24,623. Okay. All right. Assumption 4. Assumption 4 is 20 years, paid semi-annually, stated rate of 12%, effective rate of 10%. Okay. So we'll have the 12 divided by 2 again, which is 6% times 1 million. That should equal 60,000, which is what we have. Our interest is going to be for 5% still, but that number of periods is going to be 40 now. Remember, it's 20 years. Interest is calculated twice a year, so 2 times 20 is 40. And our interest with the effective rate is 10%, right here, 10%, so that makes it 5%. And our principal is also at 20, not 20, but 40 periods at 5%. So if we go to table 4 and we look at the number of periods to be 40 and the interest of 5%, our factor is going to be 17.15909. For the principal, if we look at table 2, 40 periods at 5%, the payment factor for that is going to be 0.14205. So let's insert our factors into our formulas here. Okay. So our total present value price for the bonds is $1,171,595 for assumption 4. Okay. All right. So let me copy this again. Okay, special, all sources and themes. Okay.